we want to solve z cubed minus 6z squared plus 11z minus 6 is equal to 0. We're going to use the factor theorem to find a linear factor of the left-hand side. The nice thing is we only need to worry about factors of 6. So I'm going to start by letting f of z be z cubed minus 6z squared plus 11z, take away 6. And let's try f of 1 to start with. So I get 1, take away 6, plus 11, take 6. And that's equal to 0. So that means that z minus 1 is a factor. So we already have a factor of the left-hand side. So z cubed minus 6z squared plus 11z minus 6 is equal to z minus 1 multiplied by a quadratic factor. Now to get z cubed at this end, we have to start with a z squared here, and then when we expand out, z times z squared gives me z cubed. Since I have a negative 1 at this end, to get negative 6 at the end of the left-hand side, I need a plus 6 at the end of the quadratic, and then I'm not sure what's in the middle, so I'll just write az. But we can find that az by looking at coefficients of z squared. You could also use z if you wanted to. But I'm going to use z squared. So on the left-hand side, I get negative 6. What would give me a z squared over here? Well, that would. And I would have, therefore, negative 1. And that would. So I would get az squared from that. And that tells me that a is negative 5. So we have z minus 1, z squared minus 5z plus 6 is equal to 0. Now, can we factorize this quadratic? So we've got z minus 1, and we can factorize that as z minus 2, z minus 3. And so we can see that z is equal to 1, 2, or 3. So this is a situation with 3 distinct real roots.